This video is part 2 for September 14th and 15th, putting all transformations together for sine and cosine. So I already did number 3 and 4 in the previous video. I'm going to go on to number 5 and 6. Starting with number 5, let's start listing the transformations. We'll start with a negative here. So this negative tells us that we need to reflect. So if we multiply sine or cosine by a value, we're going to have to reflect. So we know we need to do that. Also, we can think about cosine as being multiplied by a -1. And if cosine is being multiplied by a -1, that means our amplitude is 1. Alright. So we need to have reflect. Amplitude is going to be 1. We're not adding or subtracting anything outside of the parentheses, so we're not shifting the function up or down. X is not being multiplied by anything. If x is not being multiplied by anything, then our period is 2 pi. Really, we're multiplying by 1, but so our period stays at 2 pi. And then minus subtracting in the parentheses tells us to move or shift to the right pi. So we shift to the right pi units. Okay. So let's go ahead and graph our function. So if our period is 2 pi, go ahead and do this. Yeah. Alright. Our amplitude is 1. We are not moving it up or down, so we can stay at 1, -1. Okay. Now, here's what I'm suggesting. Cosine is really being multiplied by -1. So let's draw the dotted line. If cosine, the parent function, starts at 1, let's multiply that by -1. So 1 times -1 would be -1. At pi over 2, the function's value is 0. 0 times -1 is 0. At pi, the parent function cosine's value is -1. -1 times -1 will give us 1. And then similar thing for these points. I'm going to do this as well. So this is going to be my dotted line. This is not necessarily the parent function, but it is the parent function reflected with an amplitude of 1. So let's check off our transformations, see what we need to do left, see what needs to be done to complete. So reflect. Did we reflect? Yes. Cosine starts at 1, but now it's at -1. So we reflect across the x-axis. Check. We did that. Is our amplitude 1? Distance from here to there, 1. Here to there, 1. Here to there, 1. Check. We did that. Is our period 2 pi? Well, we start here, we go up, come back down. Bam, that's where we started. That's at 2 pi, so our period is 2 pi. Check. Now what we have left to do, what we need to do is move it to the right pi units. So I would always start on the y-axis. Our y-axis here. So our x value is 0. I need to then move to the right pi units. Well, if I move here, that's pi over 2 units. So I need to move to the right here. Plot my point. That's pi units. So notice 1, 2 tick marks. 1, 2, 1, 2, 1, 2, 1, 2. And so our function looks like this. Okay. So we need to be careful that we take consideration of all our transformations. We reflected. Our amplitude is 1, period is 2 pi, and we shifted to the right pi units. So we're good. Let's go on to number 6. So number 6, we have 2/3 sine of 3x minus 1. Well, I'm going to just start with 2/3. So 2/3 tells me the amplitude would be 2/3. All right. If x is being multiplied by anything, then that's dictating our period. And whatever x is being multiplied by, let's divide by that value. So we're really doing 2 pi divided by 3, or we could say 2 pi times 1/3, the same thing. Okay, we're really dividing by this value. That's what we did here. We really did 1/4 to 2 pi divided by 1/4. We multiplied 4 over 1 because it's reciprocal. And so our period here is 2 pi over 3. And the minus 1 tells us to shift down 1 unit. No reflection because there's not a negative here. We're not multiplying sine by a negative. We're not going to move left or right because we're not adding or subtracting anything inside of our function. Our amplitude is 2/3 and we're shifting down 1 unit. So what I'm going to say is, let's say 1, 2, -1, -2. But our amplitude is 2/3. So I'm actually going to cut this. What might be helpful is to cut this up into thirds. And then let's deal with the period. So a period of 2 pi over 3. Now, if we take 2 pi over 3 and cut it in half, we're really multiplying by 1/2. Or think of it this way. Here, 1, 2, this is 2 pi over 3, so this would be pi over 3. Half of pi over 3 would be pi over 6. And so now we're kind of counting by pi over 6. So this is 1 pi over 6, 2 pi over 6. 2 over 6 simplifies to 1 over 3. 3 pi over 6, but then 3 over 6 simplifies to pi over 2. And so then we can move the backwards. Okay. Now I'm going to continue using the same technique that I've been using. So the sine parent function, quote unquote, starts at 0, 0, 0. I'm going to multiply that by 2/3 to get 0. Then, because we're multiplying by 3, here this would go up to 1. 1 times 2/3 is 2/3. So I would end up there. Pi over 3 would be back at 0. Here the function's value, if the parent function is at 3 pi over 2, but we're multiplying it by 3, this would be -1. -1 times 2/3 would be -2/3, and then 0. So this is what our function looks like. Okay. So let's check. Amplitude of 2/3. Is our amplitude 2/3? Well, from here to there is 2/3. Here to there, 2/3. Here to there, 2/3. So I'll put a check there. Did that. Period of 2 pi over 3. Well, if I start here, it repeats at 2 pi over 3. So we did this. So our period, we took care of that. The last transformation we need to do is shift down 1 unit. So again, let's start on the y-axis. 0, 0. If I go down 1 unit, this would be here. Now, the reason cutting into thirds is helpful is because, look, we went down 1, 2, 3/3. So here, 1, 2, 3/3. 1, 2, 3/3. 1, 2, 3/3. 3/3. Make sure that's right. And so our function looks like this. So that's our function. And so we have shifted down 1 unit, and that's our function. So I think that if we can make a list of the transformations, try and take care of the amplitude, the period change, and a reflection, like we did here. Trying to take care of that, making that our dotted line, then we can move it up, down, left, or right. I'll probably have 2 more videos with this. I probably won't do all the back page, but I will try and do 7, 8, 9, 10 and post that online as well.